Hi students, we are going to study today the chapter pair of lines. Pair means a combined line. There are two types of lines, pair of lines. Combined line passing through origin and the lines which are not passing through origin. First we discuss the lines which are passing through origin. So now first clear up regarding it. To show that the combined equation of pair of lines passing through origin, I am going to consider here the lines which are passing through origin, that means lines passing through origin is homogeneous. Homogeneous means what? The equation in which degree of each term is the same. For example, x plus y is equal to 5. What is the degree of x? 1. What is the degree of y? 1. It is degree 1. That is ax square 2. 2hxy, x is to 1, y is to 1. 1 plus 1, 2. by square 2. When in the equation degree of each term is the same, then it is called a homogeneous equation of degree. Whatever the degree we want here, to show that the combined equation of pair of lines passing through is homogeneous equation of degree 2 in x and y. That means there are two variables x and y and their power of every term is 2. Is a homogeneous equation of degree 2. Listen here now, the theorem that I am going to give the proof. These are the two lines I have shown here. U is equal to a1x plus b1y is equal to 0 and v is equal to a2x plus b2y is equal to 0. As you know that when the lines passing through origin, there is no separate constant, only x and y are both are present. If x only present, it is a line parallel to y-axis. If only y is present, the line is parallel to x-axis. But I don't want the lines which are parallel to any axis, but I want those type of line passing through origin. So no separate constant, because if you get 2x plus 3y plus 4 is equal to 0, it is not the line passing through origin, since 4 constant is there. And that's why I have taken here, that is 2x, that is a1x plus b1y is equal to 0 and v is equal to a2x plus b2y is equal to 0. Understand why I have taken like this equation? If any problem is there, ask me then. Listen here, a1x1, that is a1x plus b1y is equal to 0 and a2x plus b2y is equal to 0 are the two lines passing through origin. Is it clear that why the equations are like this? No separate constant, only x and y are present. Okay? Proof here. Let u is equal to this one, a1x plus b1y is equal to 0. v is equal to a2x plus b2y is equal to 0. B2 lines passing through origin. Passing through origin. Consider the locus. Consider any locus. Locus means what? A collection of points satisfying certain mathematical condition. So I have considered one locus. uv is equal to 0. uv, I don't know what it represents. I am going to study about that. Locus uv equal to 0. So what is the first equation of u? a1x plus b1y into other bracket a2x plus b2y is equal to 0. That is the locus I have considered. Okay. Let px1 y1, any point, px1 y1, any point belongs to the line u is equal to 0. That I have considered one point on u is equal to 0. Any point here, say p. Okay. That is. Therefore, coordinates of point P, the coordinates of point P, x1, y1 satisfy the equation of u is equal to 0 since point Px1, y1 lies on the line. Satisfy means what? a1 x1 plus b1 y1 is equal to 0. Agree? Agree with me? Well, I have taken any point Px1, y1 on the line and a1 x1 plus b1 y1 is equal to 0. But I don't know whether this, consider now locus uv equal to 0 at px1 y1. I don't know whether px1 y1 satisfy this locus or not. I am going to substitute, that is, say that substitute x as a x1, y as a y1 to, that means assume that what is uv equal to 0 is satisfied or not by the point P. So a1 x1 plus b1 y1 into a2 x1 plus b2 y1 is equal to 0 or not. But as you know that this is equation 2, this value is 0 here. But I don't know, because point px1 y1, that is the point, does not lie on v is equal to 0, therefore I don't know. But 0 into this quantity is equal to 0. So therefore px1 y1 satisfy the locus uv equal to 0. px1 y1 satisfy the locus uv equal to 0. That means similarly any point qx2 y2, any point qx2 y2 on v is equal to 0, what will happen on v is equal to 0? Coordinates of point q satisfy the equation va2 x1 a2x plus b2y is equal to 0. So I get here a2x2 plus b2y2 is equal to 0. And if I consider the locus uv equal to 0 at the point qx2 y2, what will happen? a1 x2 plus b1 y2, a2 x2 plus b2 y2 is equal to 0 or not. Now here comes a1 x2 plus b1 y2 into 0, because I know that the point lies on it, but here I can't say. But this into 0 again 0. So similarly, I say similarly any point qx2 y2 on v is equal to 0 due to a2x2 plus b2y2 is equal to 0 satisfy the locus uv is equal to 0 as above. Do you agree with this? Yes. Now consider the point of intersection of u is equal to 0 and v is equal to 0. Who is the point of intersection of these two lines? It is the origin. Coordinates of origin, which is the point of intersection of u equal to 0 and v equal to 0. That means lines are passing through origin. Now origin is their common point of intersection. So O00 obviously satisfy the locus uv equal to 0. uv equal to 0, that means a1x plus b1y into a2x plus b2y is equal to 0 is not when x equal to 0, y is equal to 0. So first is 0, second is 0. Obviously, that is, it satisfies the locus uv equal to 0. It shows that uv equal to 0 is the locus which is very important. It shows that uv equal to 0 is the locus which is satisfied by the points either on u is equal to 0, that just now we have shown that px1 y1 u is equal to 0, or v is equal to 0, that is qx2 y2 on v equal to 0, or common to u equal to 0 and v equal to 0, that is origin. That is, but the locus uv is equal to 0 is not satisfied by the points which is neither on u equal to 0 or v equal to 0. If you take any point r, say x3, y3, which is not on u is equal to 0, obviously x3, y3, these coordinates do not satisfy the equation u is equal to 0. Obviously, it is not on v is equal to 0, so it does not satisfy the equation v is equal to 0. So the point which is neither on u is equal to 0 nor on v is equal to 0 do not satisfy the locus uv equal to 0. And definitely, therefore, it can be said that, yes, uv equal to 0 represents combined equation of pair of lines passing through origin. Obviously, the uv equal to 0 is only satisfied by the points either on u equal to 0 or on v equal to 0 or the common point to u equal to 0 and v equal to 0. Therefore, we can say that it is a combined equation of these two lines uv equal to 0. For the sake of simplifying, there I have taken that equation a1x plus b1y, a2x plus b2y is equal to 0, making the simplification of that a1 a2x square plus into bracket a1 b2 plus a2 b1 into xy plus b1 b2 y square. See that. a1 a2 x square, a1 x into b2 y, a1 b2 xy, a2 b1 xy plus b1 b2 y square is equal to 0. Let a1 a2 is equal to a1 b2 plus a2 b1, let it be denoted by 2h, and b1 b2 is equal to b. The equation becomes ax square plus 2hxy plus by square, because a1 a2 is equal to a. So a1 a2 is equal to a1 b2 plus a2 b1 is equal to 2h, and b1 b2 is equal to b. Ax square plus 2hxy plus by square equal to 0. Observe, degree of ax square is 2. Degree of 2hxy, x raised to 1, y raised to 1, 1 plus 1 becomes a 2, and plus by square equals 0. So degree of every term in the equation is a 2. So therefore, which is a homogeneous equation of degree 2 in x and y. What it represents? The combined equation of pair of lines passing through origin. Right? And therefore, our theorem is proved. That is, the combined equation of pair of lines passing through origin is a combined equation of pair of lines passing through origin is homogeneous equation. Homogeneous, every term has a sentence. Homogeneous equation of degree 2 in x and y. Ax square plus 2hxy plus by square equal to 0. Right? Now we come to the theorem 2. Observe here. It is a converse of first theorem. In the first theorem, what we have observed? The combined equation of pair of lines is a homogeneous equation of degree 2 in x and y. Now we have given a homogeneous equation, and to show that it represents a pair of lines passing through origin. And remember that some students always get confused with these two theorems. So for the first theorem, when it is given that the combined equation of pair of lines, draw the figure. And when it is given here that the equation ax square plus 2hxy plus by square equation is given to you, show that, don't draw the figure. Draw the figure after completing this theorem. Right? That means you don't get confused. Listen here now. So show that every homogeneous equation of degree 2 in x and y, in x and y always represents pair of lines passing through origin. That means homogeneous equation is given to you. Consider the homogeneous equation of degree 2 in x and y. That is, let ax square degree 2, 2hxy degree 1 plus 1 2, by square degree 2, homogeneous equation of degree 2 in x and y. Let us consider some cases. Case 1, a is equal to 0. What will happen then? Therefore, this equation becomes, this is due to that 0 plus 2hxy plus by square is equal to 0. Is it okay? Yes. Are you comfortable about it? Then take the common y. What will get? 2h plus by is equal to 0. So make the separate. And there is, since you know that the locus u equal to 0 gives a u equal to 0 and v equal to 0. Right? So that's why y is equal to 0 and 2h plus 2hx plus by, 2hx plus by is equal to 0. Y is equal to 0 is x-axis. Y equal to 0 is the equation of x-axis. It is also a line. X-axis is also a line passing through origin. Whereas 2hx plus by equal to 0 equation contains only x and y. Only x and y. No separate constant. But no separate constant. Therefore, equation 2hx plus by equal to 0 represents line passing through origin. Just before in first theorem I discussed about that. When the equation contains only x and y without any separate constant, it always represents a line passing through origin. So in the case when a is equal to 0, ax square plus 2hxy plus by square equal to 0 represents pair of lines passing through origin. Agree? Yes? Agree there? Two lines are there. One is y equal to 0 and second 2hx plus by is equal to 0. Listen here. 2hx plus by is equal to 0. Right? Consider second case. A is not equal to 0. You can consider also B is not equal to 0 or B is equal to 0 also. But only just A is not equal to 0, that's why I consider A is not equal to 0. The same there. When A is not equal to 0, to consider our equation homogeneous, ax square plus 2hxy plus by square equal to 0. Now, when we are considering A is not equal to 0, then multiply both sides by A. If you want to consider, to start with the theorem, B is equal to 0, B is not equal to 0, so multiply by B. But I just take only A. Okay? Multiply both sides by A square x square plus 2ahxy plus aby square equal to 0. I multiply this equation only by A. So, now considering these two terms, to make the complete square, I want a last term, third term. So third term, here a square x square is there. So a square x square is there. I want only h square y square. I have taken the h square y square to make the complete square. So a square x square plus 2ahxy plus h square y square. But there is no term. So minus h square y square and plus aby square equal to 0. Same. What I have taken there, a is not equal to 0. I multiply this equation by a, this equation. Now consider first two terms, make the complete square, taking their h square y square, the last term. So ax hy is there. So minus this one and plus. So this is the complete square. Square root of first term ax, sine of the middle one plus square root of last term hy bracket square. It is a plus b bracket square. A square plus 2ab plus b square. That's the formula. Minus, take the y square common into bracket h square. Sign changes. Minus ab is equal to 0. Do you agree? Yes. So I make the complete square here. Therefore now ax plus hy bracket square minus into bracket. I have written like this. Y square can be y. And h square minus ab can be root of h square minus ab bracket square. Because the y square into h square minus ab when making the square is equal to 0. Why I written like this? Because I want this term in the form of a square minus b square. A square minus b square. So y square y, this is a root square. Don't write h and minus root ab. This is not the square root. Root of h square minus ab bracket square is equal to 0. Now this is a square minus b square. So therefore now a plus b, a minus b. So this is your a plus, that is your b into other bracket. This is a minus b is equal to 0. As per the previous, so this can be written ax plus these two terms contain y, so I take the y common from these two terms. Here get h plus root of h square minus ab, and here ax plus y common, h minus root of h square minus ab is equal to 0. Everybody agree? Yes. So this is a square minus b square, a plus b, a minus b. I collected the terms of y together. X is as it is. And therefore, separate equations of these lines as u equal to 0. First, ax plus y into h plus root of h square minus ab is equal to 0 and ax plus y into bracket h minus root of h square minus ab is equal to 0. That is ax plus y into root of h plus root of h square minus ab is equal to 0 and ax plus y into h minus root of h square minus ab is equal to 0. Observe these two equations. Both the equations contain only terms of x and y, but no separate constant. This is term of x, this is term of y, this is term of x, y. No separate constant means plus something constant. Right? Otherwise, आप बता देंगे कि वो h minus root of h square minus ab ये constant, ये इसको multiplication है. So this is no separate constant. Therefore, these two equations represent line passing through origin. These two equations represent lines as a passing through origin, right? Therefore, in the case when a is not equal to 0, just now we have shown that homogeneous equation of degree 2 always represents lines passing through origin. Just now we say, what are the equations of the separate equation? Ax plus y into bracket h plus root of h square minus ab is equal to 0 and ax plus y into bracket h square minus ab is equal to 0. Alright? H plus. Okay? These are the two separate equations of this line. Now listen. Now case number 3. H is not equal to 0. Generally, we are not taking the case. Nobody is taking the case like this. H is not equal to 0. But see that. Then equation ax square plus 2hxy plus by square equal to 0 becomes ax square plus by square equal to 0. Due to h, it becomes a 0. Now, it can be factorized. It can be factorized only if a and b have the opposite sign. Otherwise, a square minus b square, we have the factors a plus b, a minus b. If a square plus b square is there, we cannot factorize. We have the factors, but it is a complex frame, a plus ib, a minus ib. But we are always in a real frame, and therefore we cannot factorize if a and b have the same sign. But if a have opposite sign, it can be factorized if a and b have opposite sign. Then using a square minus b square equal to a plus b and a minus b equation, ax square plus 2hxy plus by square equal to 0 represents pair of lines passing through origin. This is the case. Next, case 4. Now, let b is equal to 0. Let b is equal to 0. Okay? We have taken similar as a is equal to 0. We shall write almost all the cases consider, right? So b is equal to 0. Then the equation become ax square plus 2hxy plus by square equal to 0 become ax square plus 2hxy plus 0 is equal to 0. I am considering almost all total cases there. If x common into bracket, ax plus 2hy is equal to 0. Make the separate equation. Separate equations of lines x equal to 0 and ax plus 2hy is equal to 0. Now x equal to 0 is what? Y-axis. Oh, it is also line passing through origin. It is also line passing through origin, and ax plus 2hy equal to 0 equation represents line passing through origin. Since ax plus 2hy contains only x and y, no separate constant, therefore it represents line passing through origin. Therefore, in the case when b is equal to 0, equation ax square plus 2hxy plus by square. This is the cases. Next, that is case 5. If b, there what we have done, multiplying both side by a, then making the complete square. Here what to do? Complete the last two terms, the complete square, and then continuing same as to no need of writing again in the theorem. Similar to case a is not equal to 0, it can be shown that equation ax square plus 2hxy plus by square equal to 0, all